All right, guys, so today we're going to be annotating your periodic table. Now, there's a lot of things going on in this one, and you have the star table that's going to be used on your star test. So there's going to be a lot of things that we can put on here and a lot of things that we can manipulate. And you can do this the moment you get your star test, right? The moment you get that test, bust open your periodic table and write down some of these notes, and I promise you it'll be something that you won't forget, and it'll help you understand what this whole periodic table is about. So let's go ahead and get started. So you can see the atomic number, you can see the symbol, atomic mass, okay, you can see your little elements squared. Now, when you have your atomic number, remember, your atomic number tells you your number of protons and electrons. And how do you find your neutrons? So your neutrons are basically, you're going to use your mass there. And when you use your mass, you are going to subtract your mass, so in other words, 28 minus 14, which is equal to 14, and this would be your neutrons. Those are your neutrons. Now, why is this? Your atomic mass is your nucleus. Your atomic mass is your nucleus, so that's just a very easy way for us to remember that. Now, let's look at your actual table. Let's jump into this table. You have a total of 18 groups, and you can see the number right on top right here. So all the way down, and I'm circling each one of them so you're able to identify each of your groups. So you have a total of 18 groups. Now your groups, and I'm going to put this information up here on the top, your groups are your columns. Now remember, columns go up and down, okay? Columns go up and down. So your columns in this case also tell you your number of valence electrons. Valence electrons. Remember, your valence electrons are the electrons that help with reactivity, and they tell you how is the last number of electrons in the shell, right? So the last shell, how many electrons are there? So a very easy way to remember this, guys, is to look at the A number. So you have this A number right here, which I'm marking in blue. Now, for your valence, I don't want you to worry about these over here. So I'm actually going to cross those out for right now. I don't want to get confused, okay? Now notice, for group 1, you have 1 valence. For group 2, you have 2 valence. Now for these groups here, it gets a little weird, right? So you have 13 and then it asks for 3. So an easy rule to remember, if you're not looking at that 3A number or 4A, what you can do is when you have that 13, go ahead and cross out that 1 right there, leaving you a 3. The same thing with group 14. How do you remember? Cross out the 1. Boom, valence of 4. So in other words, everything in this group, group 13, has a valence of 3. Okay, very easy way to remember that, guys. Very easy way to remember that. Now, that's your groups tell you that. Then you have these wonderful periods on the side, which I'm going to circle over here. You have 7. Now, your periods are your rows. Periods are your rows, right? And these go in this direction. So I'm going to put rows. Now, what do these tell you, guys? Your periods here tell you, and I'm going to write it up here, your number of shells. Your number of shells. So, in other words, if you are in group 7, or in your period 7, this whole row right here has 7 energy levels, 7 shells. So if we want to talk in terms of maybe we're playing some Battleship or making connections, right? You see group 2, so if I'm looking at magnesium has 2 valence and has 3 shells, right? Very easy way to remember that. Very easy way to remember that. Now let's talk about your group names, right? Let's talk about your group names. So group number 1, we're going to focus on just 4 groups. Group number 1 are your alkali metals. And I'm going to put on here, they're the most reactive. They are the most reactive out of your entire periodic table. Then we're going to talk about group number 2, which is your alkaline earth metals. So group 1 is your most reactive. Group 2 is also very reactive, but that's just one of the names that we need to remember when we talk about our periodic tables. Next group I want you to remember is group 17. Now I'm going to kind of go up here a little bit, okay? And we're going to call these the halogens. Now the halogens are the most reactive non-metal group. So the most reactive non-metal group. Okay? Most reactive non-metal. Then we're going to go into our noble gases, which is group 18. Noble meaning good. So this group here, guys, is your most stable. So you can see, guys, as we go down the entire periodic table, as we go in this direction, right? So if we're going from the beginning over here to group 1, and we're moving in that direction, it becomes less reactive. Less reactive. In other words, here, the only one that is the only exception, which in this case would be your group 17, which is your halogens. Everything else as you go down that table becomes less reactive. Now, how do we know that? Because of your valence. So reactivity tells you your valence, and I'm going to write this in big words here because it's very important, is your reactivity. So we know how something is, we know how something reactive is, or it has stronger chemical properties by its reactivity, by its valence. So let's break down, guys, what is on this table as well. So what I'm going to do is I'm going to try and color code the best as I can so that y'all can see the different colors. So first what we're going to look at is this little hydrogen up here has an only little exception. This over here, guys, is a gas. So I'm going to put a big G right here for gas. Now, everything on this table, guys, is separated by what we call a staircase. Now, we have a wonderful staircase here, which is outlined on your table, which separates your metalloids, your metals, and non-metals. Now, your metalloids, guys, are located in this area. Everything that the staircase touches. Okay, so you can kind of see those areas here. Okay, those are your metalloids. So I'm going to label them here. These are my metalloids. Those are my metalloids. So everything from this side is a metal, with the exception of hydrogen, and everything on this side is a non-metal. All right, and last thing we're going to cover are the properties of each of these groups. So I'm going to kind of separate here. Now my metals, the way I know I have a metal, include things like luster, which means shininess, how shiny it is. The majority are solids. They're malleable, meaning they can bend, they can be moved into different shapes. And they are good conductors. And conductors of heat and electricity. Heat and electricity. Now let's look at non-metals. Non-metals are brittle, which means they break easily, dull, and which means not shiny, right? And then these are bad conductors, right? So we don't need if we understand that a metal is a good conductor, over here, this is a bad conductor. Okay, that is a bad conductor. And then finally, we have our metalloids. Now, our metalloids have properties of both properties. Now, this is very important to understand because these metalloids are kind of located in the middle, what that we discussed. So it makes sense that they share properties of both. So if something has a high luster, meaning it is very shiny, but can also break easily, we'd consider this a metalloid. So I know there's a lot of information going on here on this periodic table, but what I want you to understand is that if you have trouble with any of these concepts as you're looking at this periodic table, maybe your concept that you struggle with is knowing what your periods are. Only annotate your periods. Only annotate this side. If you want to write down your metals, nonmetals, and metalloids, put those on there as well. If you forget the names of your groups, put those. Again, work with your strengths and see exactly what works for you. But this is the best way to annotate and put the information that you need in order to be successful for your periodic table.